This video will demonstrate how to constrain one of the cams that you've made to the automata test. In this case, when you first unzipped your folders, you probably noticed a lot of different files. We're going to be opening up the file that says automata simulation test.iam. The .iam means that this is an assembly file. An assembly file is a collection of all the different parts, and it'll demonstrate how the pieces can move together. Now you're going to notice the default setting here is that you have a crank attached to an axle. The default has a hexagonal cam in the middle that touches the follower. Then we've also got this ruler on the side, and we've got a scale on the back that shows our degrees. And this will end up becoming beneficial later on. Notice when you turn the crank that the scale and the follower move with it. Ultimately, we're going to be using this to create motion graphs so we can trace at which degrees our follower changes positions. Now for my example, I'm going to be constraining the Pear cam instead of this hexagonal cam. So the first thing we're going to do is we're going to remove the hexagonal cam from our assembly so we can put a new one in. Remember that the browser shows a history of everything that's been done in this file, so you can see there's quite a few parts that have been added in. You need to find the hex cam, and we're going to just right click to delete that. From here, we want to place the cam that we're going to add in instead. So I'm going to use this drop down menu in the top left corner and just choose place. You should have your file saved on your H drive, and we're going to choose the Pear cam first. Now notice that my Pear cam does have all those work planes that I put in earlier. You also notice when you start placing this that sometimes it tries to place multiple cams at once. We only need one. So if it tries to do multiple cams, just right click and hit OK so that you only get one added. If your Pear cam does not have the two work planes and the axis in the center, then you need to pause this video here, go back to the work planes video, and add in the work planes before you continue. Now we're going to be using a series of what we call constraints in order to put this cam on the axle. The constraint menu is at the top of your screen, and there's all different types of constraints we can add. Today we're going to be using one assembly constraint called a mate, and then a transitional constraint at the end. I'm going to use my mate constraints first, and I'm going to start by lining up the center of my cam with the center of my axle. So this is where we're going to use the work axis. So I scroll in, I'm going to select my axis and zoom back out and do the same on the axis that goes through the axle. And you're going to notice that my cam turned so that those axles are now lined up. I'm going to hit apply to save that. And if I wanted to, notice that right now I can spin my crank, but the Pear cam is not turning with it. So my next step is going to be to align my Pear cam with that crank's work plane. So I'm going to pull up in the constraint menu again. I'm use that same mate constraint, so I don't need to select anything. Mate's the default setting here. And I'm going to click on the work plane of my cam. This one, I'm doing that perpendicular one, along with the work plane on my axle. And notice now that my cam has been tilted, and now when I crank, it spins with. Okay. Notice right now that if I zoom out, when I spin, my Pear cam's turning, but it's not attached to the follower at all. So my final constraint at this point is to attach to the follower, because we look at right now, I can slide this back and forth. We don't want to be able to do that. Now you're going to notice if we look at our follower, okay, we don't have the correct work plane turned on right now. So I'm going to have to find my follower in the browser. Remember, you can hit the little arrows to expand and see your options. I'm going to go into the origin folder, and I'm going to turn on a work plane. In this case, it is my YZ. Remember, you right click and select visibility to be able to see it. So now I've got a perpendicular work plane on my follower that matches the one on my cam. So I'm going to apply one more mate constraint, and I'm just going to select the mid plane on my cam with that perpendicular one on my follower. And now you'll notice that they're facing the same direction, and I can't move the cam up and down along the axle anymore. Okay. Now, notice that when I spin my cam, it's not actually pushing the follower up and down. So the final step is to add a motion constraint, and that's what we use the transitional constraint for. So I'm going to go up to my constraint menu, and I'm going to select the transitional constraint. And then this is where we have to select the pieces that we want to touch and move. So I'm going to zoom in first on my follower. The order that you select these in is important. And we want to click on that curved face on the bottom of the follower first. And I'll have to spin my view around a little bit. And I want to select the bottom of the Pear cam. I hit apply. And now we're going to come back and test it. And notice now when I spin my cam, the follower is moving up and down. So if you reach the point where you spin and your follower moves up and down, you've completed this assembly. Now what we're going to want to do is we want to create a copy of this for each different cam. So when you get ready to save, you're going to go to File, and then you're going to hit the little arrow next to Save As and do Save Copy As. And just change the name at the end to add in what cam you put in. So I'm going to call this the test Pear. And then when you get ready to start your next one, you're just going to open that same test file at the beginning, repeat the process, but with a different cam.